Today, we're going to dive into a playbook that's pretty much essential for anyone building with AI right now, the AI Engineer's Handbook. In a field that seems to change every single week, this guide really focuses on what's going to matter for the long haul. So let's get right into it. Right from the get-go, the handbook hits us with this really crucial idea. Success in AI? It's not about memorizing all the latest jargon or knowing every complex architecture. No, it's about one thing and one thing only: applying this incredible technology to solve real human problems. And honestly, that single principle is the foundation for everything else we're about to talk about. And this is the fundamental shift that every developer really needs to let sink in. For decades, your value was directly tied to the code you wrote. Well, that era is ending. With AI already writing over 80% of the boilerplate code and unit tests, your role just has to change. So what is your job now? Your new role is to be the architect. You design the system, you draw up the plans. In AI, it acts as your unbelievably fast construction crew. This whole explainer, this is that blueprint. We're going to cover the mindset, the models, and all the methods you need to master this new role. Okay, first things first, we've got to talk about the mental model. Before you even think about writing a single prompt or an API call, you have to understand what this tool really is and, just as importantly, what it isn't. Getting this right is the absolute foundation for everything else. So the best way to think about AI is what the handbook calls the intern analogy. Just picture the AI as this brilliant, lightning-fast intern. It's read the entire internet. It can write, it can reason, it can code. But, and this is so crucial, it has zero memory between your requests, it needs crystal clear instructions, and it can confidently hallucinate, just make stuff up. You wouldn't let a brand new intern ship code without a review, right? Well, the exact same principle applies here. And here's what that mindset shift looks like in practice. Old school skills like memorizing syntax, they're becoming way less critical because, well, the AI can handle that. Your value now comes from these higher level skills. Prompt engineering, so you can give those clear instructions. Evaluation design, so you can actually test the quality of what comes out. And a deep understanding of model limits, so you always choose the right tool for the job. Okay, now for the brains of your operation, choosing the right model. This is probably the first major technical decision you're going to make, and believe me, it has huge implications for your project's cost, its speed, and its overall quality. So here's a quick snapshot of the big players in early 2026. You've got Claude Opus 4.5, which is just crushing the coding benchmarks right now. There's Gemini 3 Pro with its absolutely massive 1 million token context window, and of course, some really powerful open source options like Llama 4. But you know what? This slide is going to be out of date in 6 months. Don't even bother memorizing it. Instead, this framework, this is what you should memorize. Instead of just chasing the latest and greatest model, you map your requirement to a model type. So you need the absolute best code quality? Go look at the top of the SW Bench leaderboard, which happens to be Claude Opus right now. Need the lowest possible cost for a super high volume task? You're probably looking at something like Gemini Flash or Haiku. Need to run it on your own servers on-prem? Well, that's where Llama or DeepSeek come in. See? This framework is timeless. All right, so you've picked your model. Now what? How do you actually talk to it? This is all about prompt engineering, and the handbook is crystal clear on this. Your instruction is your new code. A vague prompt is just like a vague spec. Garbage in, garbage out. And to avoid that garbage in, garbage out problem, you use a structured approach, something like the RICSOF framework. It breaks a great prompt into 6 key parts. You give the AI a role, you give it clear instructions, you provide relevant context, you specify a certain style and output format, and then crucially, you give it a few-shot example of what a perfect answer looks like. Following a structure like this is how you go from hoping for a good result to getting reliable, predictable ones. But what if the information you need isn't on the public internet? How do you get the AI to reason over your private company data? Well, the best analogy for this is turning a closed book exam into an open book exam. This is the key question that pretty much every company is wrestling with. These models, they're trained on public data up to a certain date. They have absolutely no idea about your internal wiki, your customer support tickets, or last quarter's sales report. The solution? It's a technique called retrieval augmented generation, or RAG for short. Their RAG pipeline is basically a 5-step process. First, you ingest all your documents. Second, you chunk them up into smaller, more manageable pieces. Third, you embed them, which means turning each chunk into a vector, just a string of numbers that represents its meaning. Fourth, you index all those vectors in a special database. And finally, when a user asks a question, you retrieve the most relevant chunks and feed them to the AI as context. Just like that, the AI now has the open book it needs to answer correctly. So far, we've pretty much just covered AI that answers questions. But the next frontier is AI that actually does things. This is where we get into the wild world of AI agents, which move from just retrieving information to executing complex tasks. So, what exactly is an agent? Well, it's a system that uses a large language model as its brain to achieve a goal. It can plan out steps, it can use tools like calling an API or searching a database, it can then observe the results of its actions and then adjust its plan on the fly. It's not just a single response, it's a whole loop that keeps running until the job is done. The real key difference is the workflow. A standard call to an LLM is static, one input, one output. That's it. But an agent operates in this dynamic loop. It thinks about what it needs to do next, it takes an action using one of its tools, and then it observes the result. This thought-action-observation cycle just repeats and repeats until the goal is finally met. And this is what allows agents to tackle some truly complex problems. All right, let's bring this all together. You've got the mindset down, you can choose a model, you know how to prompt it, and you can even build agents. So how do you build robust production-ready systems and, build a career that actually lasts? This brings us to what is arguably the single most important skill in the entire handbook, evals, or evaluations. Think about it. In old-school software, a unit test is simple. It's true or it's false. But AI outputs are probabilistic. You can't just check if two things are equal. Evals are the new unit tests. They're what let you measure quality. Is this summary accurate? Is this generated code correct? Is this answer actually helpful? If you can't measure it, you can't improve it. It's that simple. And there isn't just one way to do this. You have to build an eval pyramid. At the very base, you have your fast automated unit evals. One level up, you can use a powerful AI to act as a judge for a weaker one, which is super scalable. Above that, you have human evals for the ultimate ground truth. And at the very top of the pyramid, A/B tests with real users. That's the ultimate measure of quality. And this all leads us to the final and most crucial lesson. Look, models are going to change, tools will change, but these 5 skills, these are permanent. Problem decomposition, because AI needs problems broken down into clear tasks. Evaluation design, because you always have to be able to define what good looks like. System thinking, so you can connect all the moving parts. Human judgment, to guide the tool. And of course, ethical reasoning, to make sure we use it responsibly. AI is going to augment these skills for sure, but it will never, ever replace them. And that really is the final crucial question the handbook leaves us with. The technology is here, and it's getting more powerful by the day. It's a tool, maybe the most powerful tool ever created. So the only real question left is, what real, meaningful human problem are you going to choose to solve with it?